we've been graphing. We've been graphing when the domain is a specific domain, which gives us a discrete graph. We've been graphing when the domain is all real numbers, which gives us a continuous graph. Today we're going to add with that, I can use the graph of a function, so it's already graphed for us, to determine f of x values. F of x is also known as what? Y. So I can determine the y values, the f of x values, for given x values. And I'm going to use the graph to do it. So like they did here, they used the graph to find what f of x, oh dear, f of x, also known as y, is when x is -3. So what did they do? They went to -3 on the x-axis, followed it down to the graph, and said, okay, here's where the point is that has an x value of -3. What is its y value? It is -5. So f of x equals -5 when x equals -3. So that's how we're going to identify. We're going to identify them as ordered pairs like that. Okay? So let's just go practice a couple of these. Use this graph of f of x equals 2x minus 1. Remember, that can be rewritten as y equals 2x minus 1. So we're going to use that. Instead of us having to make a table and make the graph's already made for us. So we're kind of like using the graph to get the points that help them make this. So we're going to find f of x when x equals -1. Okay, so when x equals -1. So we're going to go to our graph, and we're going to go to where x is -1. We're going to follow it down till we land on the line, and we're going to put a point there. So when x is equal to -1, we'll go to -1 on the x-axis, follow it down, because in this case that's what we have to do. Sometimes you might have to go up. This time we go down, we put a point on the line there, and we say, oh, that's ordered pair what? -1, -3. So we are going to go say f of x equals -3 when x equals -1. The f of x, the y value, is -3. So if we would have used a table, in other words, if we would have put -1 in for x, we should get -3 for y. Let's just do that quick. Let's put it in. What's 2 times -1? What's 2 times -1? -2. Subtract 1 from that, because that's what the function rule says. What's -2 subtract 1? -3. Sure enough, it's what we got from the graph. Okay, you go figure out what is the f of x, the y value, when x is 1. So what's the ordered pair name at that spot? What's the ordered pair name? What'd you get, Maisie? 1. So ordered pair 1, 1. Okay, so when x is 1, f of x also happens to be 1. Okay, how about when x is 1/2? So now we're going to go to right here at halfway between 0 and 1 on the x-axis, and we're already right there on the line, aren't we? So when x is 1/2, what's our y value? 0. 0. We don't go up or down at all, so our f of x is 0. So again, if we really actually substitute the x values into the function rule, those are the y values we should get. So let's just try that last one. If we put 0 in, or excuse me, 1/2 in for x, so we're going to take 2 times 1/2. What's half? 2? 1. What's 1 take away 1? 0. So it works, doesn't it? Okay, you go ahead and try that next one on your own. You don't have to make a table. You're using the graph to answer those questions. And I want points on your graph, and I want ordered pair names on your graph, and then you can go answer the fill in the blanks for the 6, 7, and 8.
lines mean on the outside mean opposite?
The lines on the outside mean opposite. You mean in the function rule right here? Is this what you're talking about? You're talking about this?
Nope, what do those mean?
Absolute value. Remember, that's absolute value. Okay, somebody tell me what ordered pair name you got when x equals 2. What's the ordered pair name for that one? Okay, 2, 3. So that means that f of x equals what when x equals 2? 3. The y value of your point, right? Okay. Tell me what ordered pair name you got for when x is 6. What's this one's ordered pair's name then? 6, 1. So the y value, the f of x, is what when x is 6? Is 1. Okay. How about the last one? What's this answer? Number 8. 5? Okay, so I'm hearing 5 and I'm hearing, what was the other answer I heard? 0. Okay. Any others? Any other choices here? We can only have one, but we'll see which one it is. Yes, Blake.
How would that be negative?
Which one? Number 7. You want it to be negative 1?
I don't, it won't work on the graph, but I'm just wondering, I got 5 minus 6 equals negative 1.
Yeah.
Oh, when you substitute in, you're checking it out in the function rule, aren't you? Good job. So when you take 5 minus 6, so you're saying right here when we check it out, 5 minus 6 is what?
Negative 1.
Negative 1. So we have the absolute value of negative 1. Which is positive 1. How far is it from 0? So it checks out, doesn't it? Okay, we got to figure out which of these answers would work. So maybe we could just do a check problem and see. But wait a minute. We're solving for what? We're looking for what? Are we looking for f of x this time? No, we're looking for x. I'm not so sure we know how to do that. So, you know what? Here's what we had to do this time. We had to say that, Samuel, are you with us here? We had to say that f of x is 0, which is, that means the y is 0. So we had to go to the y value of 0 and follow over to the graph until we land on it and say, what's the ordered pair name for that one? What is it? 5, 0. And this time they weren't asking us for the y value, they were asking us for the x value. So when y is 0, well, it's not that one, x is 5. So we have to be careful, what are they asking us for? Are they asking us to identify the y value, or do they want the x value? Okay, be careful about that. Okay, any questions? That's all we're doing today, along with your other 2 sets of notes that you have to help you with because the worksheet's going to cover all 3 days' notes.